What's up, my StatsRs? I'm Michael Princhak, and in this video, I want to tackle some multiple choice questions to help prepare you for the AP Statistics exam. So in this video, I'm going to present a multiple choice question. Go ahead and pause the video, try it on your own, see what you could come up with, and then hit play, and I will very briefly go over the solution and the answer. All right, best of luck. Hopefully you enjoy. So being that this is part 2 of the AP Statistics practice multiple choice questions, I decided to make them a little bit harder. Not all of them, but you'll see that some questions involve a little bit more work, especially those pesky questions that involve probability. So let's dive right into question number 11. Here it is. I'm going to present it to you. You can pause the video, try it on your own, and then just hit play and I'll start talking about the solution. So here is the question from Unit 1. All right, so the correct answer here is going to be A. The median age and range are both greater for cats and dogs. Now, the first thing that we have to notice is that this is a back-to-back Stemplot, but it's kind of weird because it goes in reverse order. The higher numbers are at the top, the lower numbers are at the bottom. So at the bottom, we see some cats that are 11 months, 12 months, 12 months, 13 months. You get the point. At the very top, we see a cat that's 104 months old. Now, how do we know that the median is more for the cats? Well, there is sometimes you can just eyeball it. I mean, just look at it, right? The cats are clearly going to be a little bit higher in the median than the dogs that are kind of clustered at the bottom. But we can actually use the formula n plus 1 divided by 2 to tell us the location of the median. Now, there's 19 cats plus 1 divided by 2 is 10. That doesn't mean that 10 is the median. That means the 10th cat, or the 10th weight in order, is the median. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 45 is the median for the cats. And if we do the same thing for the dogs, there's 17 dogs plus 1 divided by 2 is 9. That's, again, not the median. That's the location of the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That means that the median for the dogs is 21. So we can clearly see that the median for the cats is higher, even if, mostly you can see that by your own, but if you need to do the work, you can actually see it as well. Now, what about the range? Well, the range for the cats is going to be the highest cat, which is 104, minus the lowest cat, which is 11. And that is 93. That's the range. For the dogs, we see a max of 98 minus a min of 11. And for that, we get a value of 87. So once again, it's pretty obvious that the range for the cats is smaller. All of the other questions are not saying that properly, or maybe one of the statements is true, but the second half of the statement is false. The only other one I want to talk about is the mean. Now, we can actually type all these values into our calculator and calculate the mean, but the mean age and range are greater for dogs. We should automatically know that that's going to be wrong because the cats are going to be skewed to those bigger numbers. So because there are these much higher cats, then that means the mean is going to be higher for the cats, not for the dogs. So you can calculate it if you want, but that should be pretty obvious based on looking at the graph. All right, let's jump to number 12. Here it is, and it is a question out of Unit 4. All right, so the correct answer here is D. Now, I have to be honest, this is probably one of the hardest questions of all 10 in this video. I think there's about 2 that are pretty tough, but this is a tough one. So let's really take our time and explain this one, mostly because it involves probability, which a lot of kids dislike. So first, we have to understand that they're telling us that the mean number of volunteer hours is 40 and that the standard deviation is 6. Okay, so these are the community service hours that college students perform. And it does follow normal distribution, which is awesome. Now, the question asks us to find the probability that a randomly selected college student receives this certificate given that the number of service hours is less than 50. So there again, that's really important because if it just said, hey, what's the probability that somebody gets a certificate? That would actually be easy because it'd be 15%. The top 15% get a certificate, so 15% of college students get a certificate. But there's the given that makes this question really tricky. So a lot of kids will just read that first part and jump and say the answer is B, but that is of course wrong. So we have to remember conditional probability. So conditional probability in the numerator is both. So we have to both get the certificate and have less than 50 service hours. And then we're going to divide that by the condition, the probability of the condition, which is less than 50 service hours. All right, now let's talk about how to do this because getting this is actually pretty tricky and you're definitely going to need your calculator. I'm about to show you how to do this using the NumWorks calculator, but you could also use your TID4 calculator. So let's take care of the easy part. The easy part is the denominator, finding the probability that there is less than 50 hours, that a college student has less than 50 hours of community service. So if we go to our NumWorks calculator, what we're going to do is we're going to go to the distributions app and we're going to go down to normal. Now, the first thing we can do to make this a little bit easier on us is actually type in the mean and standard deviation based on our problem. That means we can actually work with the numbers of our problem, makes it a little bit easier. So we want to find the probability it's less than 50 hours. So we could choose on the left-hand side here. We definitely want to choose the less than side, like favoring to the less or to the left. And then we're going to type in here 50 hours. And because we have the mean at 4 in standard deviation 6, we could type in 50. We don't need z-scores. And we get 0.9522. So we immediately know that the probability that there are less than 50 service hours for a college student is 0.9522. And you'll see that that's one of our choices, but we don't want to choose that one because that's not the full answer. Now, the top part is the tricky part, the probability that they get the certificate and less than 50. So we first have to talk about what does it mean to get the certificate? Well, to get the certificate, they have to be in that top 15%. But how many hours is that? Well, that's where we're going to go back to our Numerics calculator. And the cool thing about the Numerics, you can do it all in the same app. So we want to know that top 15%. So I'm going to go ahead and select the top proportion now, greater than, and I'm going to come way over to the right. I'm going to type in a 0.15 here. Now to do this on your TID4, you're going to have to use the invert norm feature. But the top 15% is telling me that this starts at 46.219 hours. So to get that certificate, yes, you got to be in the top 15%, but what does that mean in terms of hours of community service? That you have 46.219 hours or more. So when I come back over here, this top part, which is getting the certificate and being less than 50, now that makes sense. That would be the probability that the number of service hours is less than 50, but greater than the 46.219. And sorry for that really messy handwriting. Let me write that a little bit nicer. That top part is the probability that the number of service hours is between 46.219 and 50, because that means you got the certificate because you were greater than 46.219, you're in the top 15%, but we also have to be less than 50. And again, this is actually really, really easy to do. And we're in our calculator here. In our Numerics, we could go back. This time we want to look in between, and the two values we will look in between are 46.219 and 50. And this is going to give us the proportion of college students in that range. And we see it's 0.1022. So that's going to be our numerator over here, 0.1022, which again is another one of our choices that's incorrect because it's just part of the answer. But if we go ahead and divide 0.1022 divided by 0.9522, we do get D, which is 0.107. So again, I spent considerable time on this problem because this is a very difficult problem. It takes multiple steps to get correct. But if you know how to use your calculator, it's actually not too bad. But a lot of kids don't always understand conditional probability, so really take your time with this one. All right, question number 13, here it is. Another question out of Unit 4/5 over probability and combining random variables. Go ahead and pause the video and try it. All right, so the correct answer here is B. Now, this is another pretty difficult problem, so I'm definitely going to take my time in this one as well. And after this, a lot of the questions are a little bit easier, but this one I'm going to take my time with. All right, so essentially they're talking about two people, Mike and John, and the question literally says, what is the probability that John makes less than Mike in any given week? So we literally want to find the answer to that question right there. Now to do this, I'm going to subtract the m to the left-hand side, so I get j minus m is less than 0. So if the difference between John and Mike is less than 0, oh, I typed that in wrong. I'm so sorry. I'm going to go back and fix that real quick. Oh my Lord. Okay, here we go. So the question says, what's the probability that John is more than Mike? More than Mike, not less. I had that wrong, sorry. So when I subtract that m over, I'm going to get j is minus m is greater than or equal to 0. So when the difference between John and Mike is greater than 0, that would mean the j was bigger than the m, which is what we're looking for. I'm going to get a positive difference. J minus m is positive difference. So to calculate this, I need to figure out the z-score, because then I could use the normal model. And why can I use the normal model? Because both of them follow a normal distribution. So that means the difference between them follows a normal distribution as well. But I can't use the normal model until I know the mean of it. So what is the mean for the difference between John and Mike? Well, that's actually really, really simple math. I'm just going to take John, who has a mean of 310, minus Mike, who has a mean of 350, and I get negative 40, which means that John is supposed to make $40 less than Mike. So we have a negative 40. Now, what about the standard deviation? This is where it gets a little bit tricky. So we're going to take John minus Mike, standard deviation for John minus Mike. Now, what do we know about standard deviation? We're not allowed to add or subtract them, but we are allowed to work with variance. So John's variance is 28 squared, standard deviation squared, instantly turns into variance. Mike's variance is 20 squared, but we also know that even though we're looking at the difference, variance always builds. We never subtract variance. It always builds up when you're looking at two things. So we're going to do 28 squared plus 20 squared. That's the total variance. Then we need a giant square root around all of that to get it back to a standard deviation. So the total standard deviation for the difference of John minus Mike is 34.409. Okay, so that means we could picture a normal distribution where the center's at negative 40 because John's supposed to make $40 less, but it varies on both sides. And what we want to look for is where is the difference 0? Because anything greater than 0 is where John would make more than Mike. Because if J minus M is greater than 0, a positive number, then that means John was more. So what we need to do now is get a z-score for this value of 0. So we're going to do 0 minus the mean of negative 40. So that is going to turn into a plus 40 divided by the standard deviation of 34.409. So the z-score for 0 is positive 1.162. So now I'm going to go to my normal distribution here on my TID4 calculator. I do have to go back. Oh, excuse me. This is on my numerics calculator. Boy, I'm off today. So I am going to go back. And because I'm working with z-scores, now I'm going to change the mean to 0 and the standard deviation to 1. And I'm going to go next. And now I'm looking for greater than. So I'm going to select greater than. And I want to type in 1.162 and hit OK. And there I go. So the probability that we have a z-score greater than 0.162 is about 12.3%. Now, again, why did I do this one more time? Because that's the z-score that represents 0 on a standard normal distribution where the mean is negative 4 and the standard deviation is 34.409. So that's how I got the answer of B, 0.1226. So pretty involved problem. I know I went through that kind of quickly, but again, this is just some practice problems for you to do. But hopefully I explained that pretty clearly, even though my handwriting is a little bit messy. But hopefully I made sense of that and you understand it. All right, moving on to question number 14. All right, here it is, a question out of Unit 1. Okay, hopefully you got the answer correct. It is D. Now, the key thing here is they do give us the mean is 50 and the standard deviation is 6. But what we need to figure out is what z-score represents the 90th percentile. Remember, the 90th percentile means 90% below. So if you're going to use a TID4, you could use invert norm, but I'm using my numerics calculator. So once again, I'm in this normal app. I'm going to go to the proportion below, selecting the one right here. Then I'm going to go over to the far right and type in 0.9, and this is going to literally find me the z-score that has 90% below it or 10% above it, and that z-score is 1.282. So if I come back over here, the idea of a z-score is it's the z-score of 1.28 equals the value minus the mean divided by the standard deviation. Now I can actually solve for the weight x that would represent the 90th percentile. So I'm going to multiply by 6 and add 50, which is why choice D is correct. All right, moving on to question number 15. Here it is, a question out of Unit 6. All right, hopefully you got this one correct. The answer is E. Basically, they're asking you, what does 90% confident mean? Now remember, in general, 90% confidence is saying, hey, listen, there are many, many, many samples out there. 90% of those samples would create a confidence interval that contains the population parameter. So if we do 150 samples, right, 90% of them, 90% of those samples should contain the true proportion of all people who exercise regularly. And that's exactly what choice E says. 90% of those 150 created confidence intervals will contain the true proportion of all, not the sample, right? The samples are going to vary. They're going to be different. So that's the correct answer there. If we look at the other choices here, none of them just don't really make sense. A says with 150 confidence intervals, we could be 90% confident the sample proportion of people who exercise regularly is correct. No, the sample proportion is actually what we'll know. A confidence interval is looking for the true population proportion. B says we would expect about 15 of the 150 confidence intervals to not contain the sample proportion of people who exercise regularly. Once again, that's actually kind of correct, but they use the word sample. Again, that's wrong. Technically, that does make sense because if 90% are going to contain the truth, then 10% will not, and 15 out of 150 is 10%. But if that choice said we would expect about 15 of the 150 confidence intervals to not contain the population proportion of all people who exercise regularly, that would be correct. But it says the word sample. And again, we're not looking for the sample. The sample proportion is what we will know, right? That's what we find on our own. It's the population proportion we're looking for. C and D also just don't make a ton of sense. E is the correct answer there as well. All right, here is question number 16, coming out of Unit 6 as well. Okay, so the correct answer here is A. So essentially what we have here is two sample proportions, right? So the first proportion we get is for pet owners, and it literally tells us of those 247 pet owners, we know that 54% get over their steps. And then if we look at the non-pet owners, which was a sample of 173, it was 47%. Okay, so looking for the standard error for the confidence interval to try to find the true difference, right? Yes, there's a difference between our samples, but that's just the difference between our samples. We're looking for the true difference. Now, how do I know what formula to use? This is where that AP Stats formula sheet's going to come in handy. So there is a box for proportions. And in the first row, we have a single sample proportion. And in the second row, we have the difference between two. And right here is the formula for the standard error when you're working with a confidence interval. So we just need our p-hats. So again, we have the 0.54 and the opposite of that, which is 0.46 divided by the 247. That was for the pet owners. And then we have the 0.47 and the 0.53 divided by the 173 for the non-pet owners. So that's our perfect formula. Again, using that directly off that formula sheet. But I do want to show you something really, really important here. In a test, this is an interval, but in a test, we would use a different formula because in a test, we have to assume that the two population proportions are equal, and we would use this formula right here for standard error, which is using the combined sample proportion. So that would be putting all of the people together, regardless if you own pets or don't, and put them all together. So if that was the case here, if this was for a test, then we'd be looking at using this answer right here of D, where we combine them together to get our combined proportion of 51%, the opposite 0.49. But again, that's for a test. So you got to be really careful knowing that I'm using this to create a confidence interval. The standard error for confidence interval is using the formula for A. All right, hopefully that makes sense as well. All right, question number 17, another question out of Unit 6. Here it is. All right, hopefully you got it right. The correct answer is A. So the whole idea here is that, we want to see if this statement is true. We've heard that 89% of eligible voters voted in the presidential election, but they think that it's lower, right? So if we're thinking about our null and our alternative hypothesis, the null would be that the true proportion is 89%. It has not changed. And the alternative is that we want to show that it's lower. So they didn't ask us to do all the work, right? They did get a sample that showed 85%. They did all the work for us, and they got a p-value of 0.032. Now, they did ask us to use a significance level of 0.05. So now we have to remember our conclusion. Because our p-value is less than our significance level, that means we're going to reject the null, and there is evidence. Yes, there is evidence that the alternative is true and that the true proportion of eligible voters in the presidential election is less than 89%. So that's why we're going to choose the answer yes, because we're below our significance level. That means yes, there is evidence. So we don't want to answer no. So any answer with no is going to immediately be wrong. And the reason why we're saying yes is because our p-value is below that significance level. If the p-value was above the significance level, then we would say, no, we do not have enough evidence that the alternative is true. So that one's really testing your ability to understand how to interpret a p-value and make a proper conclusion with it. All right, here comes question 18, a question out of Unit 1. All right, hopefully you got this question correct. The answer is D. The range of scores is greater in class A than in class B. Now, the most important thing we got to be careful of here is reading the question. They want us to not get a true response, but a false response. And the reason why D is correct is because just look at it. The range is max minus min, and the range for B is definitely greater than A. If you do a little bit of estimating on what those maxes and mins are, we could clearly see that the range for B is greater. So D is false. It says the range is greater for A. That's wrong. It's greater for B. All of the other ones are true. A is true. The median for A is greater. Just look, here's the median for A versus the median of B, so it's definitely greater. A has a larger interquartile range. That's true. Interquartile range is looking at the middle 50% from your quartiles. And if you compare those, it's definitely a little bit larger for class A. Neither has outliers. That's true. We don't see either any outliers on any of them. And E is also true because the top 25% for A, which is right here above Q3, is bigger than the max for B. Here's the max for B right here, and that top 25% is all greater. So again, D is the obvious choice, but be careful. A lot of kids misread the question. They think they're looking for a true answer, and they just jump and answer A, but they didn't read. They're looking for a false. All right, here is question number 19. And the correct answer here is A. This is out of Unit 7. So basically we're selecting a sample. We get a sample from 15 randomly selected lakes, and we know the mean and the standard deviation of our sample, right? That's what we know. We know the mean and deviation of our sample. And that's why we need to use a t-interval. The whole purpose of the student's t, the t-interval or a t-test, is when we're working with quantitative data, means, but we only know the standard deviation of our sample. If we knew the standard deviation of the population, we could do a z-interval, but in AP statistics, that's really never going to be the case. So that's the idea here, is making sure that you understand when we need a t-interval versus a z-interval. And the biggest reason why is because we only know the population, we only know the standard deviation of our sample, not of the population. So hopefully that was a pretty easy question. And last question here in a part 2 video is another question out of Unit 7. Here it is. All right, hopefully you had a little bit of time. This is a little bit of a tough one, but the correct answer here is C. Now, this question is tough because they basically want us to conduct a test, right? Assuming all conditions are met, does the data provide evidence that the mean for region X is larger for region Y? So the null would be no, the mean for X and the mean for Y are the same, and the alternative is that the mean for X is less than the mean for Y. Now, what we need to do is get a t-score, our test statistic, and the p-value. Now listen, we could do all this by hand, or we could grab a calculator, NumWorks or TID4, enter all this into a 2-sample t-test, and let the calculator get the p-value for us so we can determine the answer to the question. And, I do want to briefly just talk about how to do it by hand. I feel like maybe you should know that as well. But basically, we're going to use that formula sheet again. The second row here is for the difference between two sample proportions. So here is that standard error formula. So our test statistic is going to be looking at the difference in our samples, which would be 198.4. That was the mean for X, minus the mean for Y, 205.6. minus 0, because we assumed from the null that there was no difference. And we're going to divide that by our standard error formula, which is right here. That's the whole point of me showing you this on the formula sheets right there. So that's going to be taking the standard deviation 27.3 squared divided by the 105 from that sample, plus 31.2 squared, that was the standard deviation from Y, divided by the sample size from Y was 125. So do the math and all that, and we get a z-score, or excuse me, a t-score, oh my gosh, I'm so sorry, t-score of negative 1.866. Then you could use a t-distribution to find the proportion that's below that, and that's going to be your p-value. But what I want to show you is how you could do all of that on your calculator. It's actually really, really cool here. So if we pull up our NumWorks calculator, we're going to go to the Inference app, and we're going to select a test, and we're going to go down to 2 means, and we're going to do a t-test because we only know the standard deviations of our samples. The null is that they're equal. The alternative that we're looking for is that we want to make sure that we choose the one where 1 is less than 2. That means the difference is negative, because if 1 is less than 2, then the difference would be negative. So that's going to be less than 0. That's that first answer right there. And then we're going to hit next, and we're going to input all the statistics. So we're going to actually go and type in everything we know about the sample from X, which we're calling 1 here. And that would be that the mean was 198.4. The standard deviation for 1 was 27.3. And the sample size was 105. And then we're going to keep going down, and now we're going to talk about sample or population Y here, what we know about our sample from Y. And the mean was 205.6. Lots of different numbers here. And again, you could do all of this on your TID4 as well. Not too bad. Just got to enter everything in. And the standard deviation was 31.2. And the sample size was 125. And we're going to go ahead and hit OK here, and there it is. So there was that t-score that we got as well, and then there is the p-value of 0.03165 or 0.032. So that p-value is what we need to make the conclusion. So we come back over here, now we know what our p-value is, 0.032. Now we can answer the question, right? So this is where it's got to be a little bit careful. So if our alpha level is 0.001, we would obviously not reject an all. There would not, our p-value is not below that, so that's wrong, because it says A says yes, there is evidence. No, not at an alpha level of 0.001. We would need to have a p-value less than that, and we don't. B says yes, there is evidence at the 0.01, but not the 0.001. No, that's also wrong, because again, even at a significance level of 0.01, 0.032 is not less. C is the correct answer. Yes, there is evidence at the 0.05 level, because 0.032 is less than 0.05. So we'd say, yes, there is evidence that X is less than Y, but not at the 0.01. And then D is wrong, because it says, yes, there is evidence at the 0.05, but not the 0.05. Well, actually, no, there would be evidence at both of those levels, because at an alpha level of 0.01 and 0.05, our p-value is less than both of those. So it would be, yes, there is evidence at both of those, not one or not the other. And then E says, no, there's not evidence at the 0.1 level, and that's wrong, because at the 0.1 level, there is evidence because our p-value is less than it. So kind of a tough problem. I told you a couple problems in this video were going to be a little bit tougher. But if you know how to use your calculator, the key thing we need to get from this data is that p-value. If you use your calculator correctly, we get that p-value pretty quickly, and that allows us to really make the right choice, which is choice C here. So we got to really think about that, because at the 0.05, yes, we do have evidence because our p-value is below 0.05, but not at the 0.01 significance level. So a lot going on there for sure. All right, that's it for part 2. Stay tuned for part 3, coming out with another 10 multiple choice questions. These were a little bit harder. Hopefully you understood them, and they're going to help you ace the AP Statistics exam.